Physicists say that the universe had its beginning in an event known as the Big Bang roughly 13.7 billion years ago. Anyway, the question that arises is what caused that explosion and why it happened. Over time, we have been exploring and studying the science and history of our universe, and the Big Bang has been the predominant explanation for all that we have observed. Countless studies and thousands of researchers have worked on the examination, and the data gathered has consistently supported the Big Bang hypothesis as the primary explanation for how the universe was shaped. According to this hypothesis, dark energy is a type of energy significantly more abundant than cosmic energy and is viewed as the anti-gravitational force responsible for the continued expansion of the universe. The theory of the Big Bang has been the foundation of cosmological studies and has shaped our understanding of the universe's origins and development. Science today is vastly different from what it was before, and with technological advancements, new theories emerge regularly. We find that things we once thought to be obvious are far from it. Michio Kaku has raised the possibility of revising the Big Bang theory, as the James Webb Space Telescope has identified 750 new galaxies that look nothing like what was previously anticipated. This raises a new perspective and leads us to delve deeper into how the James Webb Space Telescope is changing our understanding of the universe. Join us on this incredible journey beyond the observable universe to uncover more details about the multitude of new galaxies that have been discovered. These discoveries urge us to reassess the very foundations of cosmology and the nature of the universe. If you're interested in staying informed about news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. The images of new galaxies captured by the James Webb Telescope are absolutely stunning. In one image, we can see many galaxies all together, and the beauty and detail of these photographs are breathtaking. However, what seems to astonish the general public is exactly the opposite for scientists. These images are astounding to them, but they do not match what researchers expected to see based on their theories. In fact, more galaxies are being observed than anticipated, and these galaxies are different from the rest. They are smaller than expected and have a surprisingly ancient age. These surprises have generated some panic among scientists. There is even an article that starts with the word alarm in its title, indicating the seriousness of the situation. These galaxies are unlike what they were supposed to be according to established theories. For years, scientists have proposed the Big Bang theory as the primary explanation for the origins of our vast universe. According to this hypothesis, roughly 13.7 billion years ago, the universe began its existence through some sort of mysterious cosmic event. However, these images challenge the definitive story of the universe's origin as previously understood. The discrepancy between theory and observation calls for a re-evaluation of long-held cosmological models and assumptions. The striking images captured by the James Webb Telescope have tested our understanding of the universe's origins. Specifically, these images directly contradict the Big Bang theory, which has long been considered an unquestioned truth by cosmology scholars. The galaxies captured in these images appear to be smaller, smoother, older, and different from the predictions of the Big Bang theory. The fact that the observed galaxies are several times smaller than similar galaxies imaged by the Hubble Space Telescope completely challenges the expected behavior in an expanding universe. According to the theory, as the universe expands, objects should appear larger as distance increases. However, these James Webb observations show galaxies that defy that assumption. Moreover, the smoothness of these galaxies is entirely unexpected. According to the theory of the universe's origins, galaxies should exhibit anomalies and variations in their structures due to the conditions of their formation and evolution. However, the images reveal unusually smooth galaxies without the complexity and roughness one would typically expect in galaxies of their age. This contradicts the expected timeline for the formation and evolution of galaxies. Inside the framework of the theory of the universe's origins, these discoveries require a reconsideration of the mechanisms of galaxy formation and the influence of massive forces over billions of years at the beginning of the universe. All matter, energy, and building blocks of the universe were packed into an incredibly dense point known as a singularity. At this point, the density reached an immensely high value due to the extreme compression of matter and energy. The concept of a singularity relies on our current understanding of the laws of physics, particularly the principles of general relativity proposed by Albert Einstein. Within the singularity, all matter and energy in the universe existed in an extraordinarily compact structure. This extreme density implies that a vast amount of mass and energy was concentrated in an incredibly small space under extreme pressure and density. Conditions such as those present in the singularity are beyond any temperature observable or reproducible with our current understanding of the universe. The energy contained in this hot, dense point was the seed from which the entire universe, as we know it today, began. The singularity marks the beginning of the universe, the start of everything in our universe. After the initial singularity, the universe began its journey of expansion and growth. This process occurred over approximately 13.7 billion years, giving rise to the universe as we understand it today. The evolution of the universe began with an extraordinarily rapid burst known as cosmic inflation. During this stage, the universe expanded at an incredible speed, far surpassing the speed of light. It is as though the very fabric of space itself expanded, pulling everything within it. Cosmic inflation played a crucial role in the formation of large-scale structures in the universe. It smoothed out inconsistencies, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. This period of inflation is essential for explaining the uniformity observed in the cosmic microwave background radiation. As the universe continued to expand, the rate of expansion gradually slowed. It is important to note that while there was rapid cosmic inflation in the initial phase, the universe continued to expand at a measurable rate. This ongoing expansion is known as cosmic expansion or the evolution of the universe. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. Redshift indicates that as the universe expands, light waves are stretched and shifted to longer wavelengths, moving them toward the red end of the spectrum. During this expansion, all the matter that makes up our universe was compressed into an incredibly small volume. It was clear that matter could not survive in such a minuscule space, so changes occurred as the universe expanded and cooled. Particles such as protons, neutrons, and electrons began to interact with the light and energy around them. These interactions played a key role in the formation of matter in the universe during the first moments after the Big Bang. This process is known as nucleosynthesis and is crucial for the creation of the elements that form the basis of all matter in the universe. Chaotic and disturbed galaxies, due to numerous collisions, were expected to be observed. However, the images captured by the JWST tell a different story. Instead of chaotic galaxies, the images reveal orderly disk and spiral structures similar to the galaxies we see in the present universe. This surprising observation challenges the notion that mergers are a typical process in galaxy formation. If these new galaxies have not experienced many or any mergers, it becomes unlikely that small galaxies would grow to become much larger. This implies that these galaxies were never small to begin with. Additionally, the optical illusion created by the expanding universe theory, where objects appear smaller due to expansion, does not hold in this case either. Thus, what we have accepted so far turns out to be an illusion. Furthermore, the age and composition of galaxies revealed by the James Webb Space Telescope also challenged the validity of the theory of how things came to be. The JWST is equipped with filters that allow imaging in the infrared portion of the spectrum, which facilitates the observation of the colors of these galaxies. By examining these variations, cosmologists can estimate the age of stars and galaxies. These new insights prompt a reevaluation of the processes that have shaped the universe. One of the key mysteries that has fascinated humanity for a long time is the origin and evolution of the universe. From ancient legends to modern scientific theories, people have continually sought to understand how everything began and how it has evolved over billions of years. Today, our understanding is largely shaped by the theory of the universe's origins, which posits that the universe began as an infinitely small, dense point and has been expanding ever since. The theory of the universe's origins emerged from a combination of theoretical physics, observational astronomy, and cosmological principles. It suggests that around 13.7 billion years ago, all the matter, energy, and space-time of the universe originated from a singularity, a vastly small and hot point. This singularity underwent rapid expansion known as cosmic inflation during the first fraction of a second after its birth. This period of inflation smoothed out anomalies and prepared for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe expanded and cooled, the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, separated and began to govern the interactions among particles and matter. This allowed for the formation of protons, neutrons, and electrons, which eventually combined to form hydrogen and helium molecules. These primordial elements were the building blocks from which stars and galaxies would later arise. The study of the early universe and its evolution has been revolutionized by advances in observational technology, such as telescopes and satellites. One of the most significant instruments in modern cosmology is the James Webb Space Telescope, JWST. Scheduled for launch in 2021, the JWST promises to provide unprecedented insights into the formation and structure of galaxies, stars, and planetary systems. Unlike its predecessors, such as the Hubble Space Telescope, the JWST is designed to observe the universe primarily in the infrared part of the spectrum. This allows it to peer through cosmic dust and observe objects that are too faint or distant for other telescopes to detect. By capturing detailed images and spectra of distant galaxies, the JWST is expected to shed light on the conditions and processes that shaped the early universe. One of the key goals of the JWST is to study the formation and evolution of the first galaxies. By observing the most distant and ancient galaxies, astronomers hope to gain insights into how these early cosmic structures emerged from the primordial soup of the early universe. The information gathered by the JWST will help refine our understanding of the Big Bang Theory and the processes that followed it. The images captured by the JWST are anticipated to provide a wealth of new data that will challenge and refine our current theories about the universe's origins and evolution. This promises to be an exciting era in cosmology, as the JWST's findings could lead to new discoveries and revisions of our understanding of the cosmos.